in the past, say a few years ago, I published a circuit of a speech filter. So you can put in, say, a normal audio, and you can change that by giving that audio a very specific bandwidth, especially to make a speech more better intelligible. The video is already on my YouTube channel. I will give the link to that earlier video a few years ago, and I wanted to make it anew, but I found, and it was very strange, that the whole circuit only wanted to work with the 741TC. This is the schematic. I also want to refer to my earlier video. There's also a demo of this circuit, and I tried other 741 types and they didn't work. Had of course not expected that, but anyway. In the earlier video there is the best demo, so I'm making it now again. This is the front plate. I want to connect it now to a small audio amplifier. That audio amplifier was also published earlier on my YouTube channel. I use now 2 loudspeakers for better intelligible of speech. And this filter can, say, limit the noise, etc, etc. Here is the end amplifier. It is on my YouTube channel. I will give the link. This is the filter. In fact, completely the same, but perhaps it's interesting to tell something about how to make it. It's not visible here, but this is here is tin plate, and also here there's tin plate. It's glued to the wood, the multiplex wood, triplex wood, and it's connected together here. It's soldered together to make it a, say, a complete metal box, and that's important because such a filter is sensitive for hum, etc, etc. So you can here see the soldering, etc, etc. And also here on the front, this is the front with all the switches, and here you can see the back side. Again, here tin plate is very thin. Tin plate is glued to the wood, and after all the components are mounted so that there is a proper shielding against hum. That's very important. And inside the circuit here, when everything is properly shielded, you can use unshielded cables. When you want to do it more perfect, you can also use here for the connections to the potentiometers that do their jobs, setting the bandwidth, output and input level. You can use shielded wires. That's, say, another serious issue, because, say, the mantle of the shielding must be only connected on one point to the steel chassis, in this case steel chassis. Anyway, so panels or what, you see the transformer that I'm using. It's 12 volt at approximately 0.5 ampere. I need it to get enough power out to the loudspeakers. The transformer is mounted in such a way that the metal, the core of the transformer, does not have any contact to the chassis here, the metal steel chassis. So it's isolated from the chassis, and the reason is that such a transformer, when you mount it directly to a metal steel chassis, that's what I mean, it can introduce, say, hum, electromagnetic fields on 50 Hertz or 60 Hertz into your beautiful shielded here environment box where you mount the audio circuit in. And to prevent that, say, induction of electromagnetic fields on 50 Hertz there is isolation here. I've used here a small piece of wood, well lacquered, etc, etc. Also the orientation of the transformer is important. The field is built up on 50 Hertz or 60 Hertz, especially here on this part of the transformer. So here the field goes out, but the field is not very strong here on this part of the transformer. So to prevent that the stray field enters the very sensitive preamplifier, I mounted the transformer in this way, and it could be that you even have to mount the transformer in a very peculiar way, not in this say straight way, to make that the electromagnetic field on 50 or 60 Hertz does not enter the sensitive input of, in this case, a filter, but it can also be an audio preamplifier. Also keep the transformer far away from the sensitive part of your audio circuit. That's here. So here we have a distance of approximately, I think, 20 centimeters or so. That could be enough. I don't know that for sure. I have to test it when everything is mounted, etc. And so could be that this distance is even too small from the transformer to the sensitive input of the filter. But anyway, so that were a few tips. And always use, by the way, for audio, this filter, a power supply that is completely free of hum, be it 50 Hertz, 60 Hertz. That's absolutely necessary, otherwise you will hear a faint hum on the background when you operate such a audio circuit. That's not okay. There are many circuits on my YouTube channel about how to do that. Say the Miller circuit, where in a certain way the value of a capacitor is multiplied by the use of a transistor, 1 or 2 transistors, Darlington or a single transistor. I'm going to use that here also. So it's not finished, but anyway, I hope these were a little interesting tips about when you want to make audio circuits in, say, the more or less old school way. Thanks for watching. And here is the schematic again. And of course, like I told, very important, only the 741 TC works in this setup. Pan over somewhat, and it will take quite a long time before everything is tested, works nice, etc, etc.